So in this question, we have a graph. So first thing we want to do is analyze it. OYXRGSA. The origin is here. And the origin is 0 is there. But the origin in terms of the x-axis is way over that way. So in terms of the coordinate plane, we're looking at this as the location, where there's a 0, quadrant 1, quadrant 2, quadrant 3, quadrant 4. The y-axis is acceleration in meters per second squared, so that's normal. X-axis, time in seconds, normal. So anything, we can read the axes, which are acceleration and time. So any questions about acceleration or time will just be read off the graph. The gradient or the slope is delta A over delta T, which by definition is the jerk or the rate of change in acceleration. So any questions about jerk or rate of change of an acceleration, that will be answered by the slope. The area is A delta T, which is delta V. The units being meters per second squared times seconds. It gives us units of meters per second. And delta V is V minus V0. So any questions about the change in velocity we'll get from the area. So we have two model cars, A and B. They have the same mass, but different bumpers. So that means they'll compress differently. The acceleration during its collision with the wall is measured, and the data are shown in the graphs above. Which statements are correct? Select two answers. So if we look at the accelerations, it's interesting to note that it's 0 until there, and then 0 again there. So acceleration is 0 there, and 0 there. So the changes in velocity are occurring between those two segments of red. Both cars achieved their maximum speed at 10.05 seconds. Well, anything to do with speed might be related to area, but we don't know the V0. That's unknown. So to know the velocity at any particular point in time, we would need to know the initial velocity, which we don't know. So we actually can't really say anything about their maximum speed. This choice is out. The cars experience approximately the same impulse. So let's lay out our four-way equivalents here. We have impulse, by definition, is the average force, times the change in time. And the change in momentum is m delta v. And of course, the impulse is equal to the change in momentum experienced by a body. So those two are equal to each other. So the cars experience approximately the same impulse. Now, delta v can be arrived at. We know the m's are the same. And the delta v's can be arrived at through the area. So if we look at the area of this here, and the area there, are they equal to each other? Because if the areas are equal to each other, multiplied by the masses, then the impulses will be equal to each other. So let's assign some values here. So this is 0.04, and this is minus 40. So the area will be equal to 1/2 base times height. So we have 1/2 of 0.04 times 40. And so that's 0.02 times 40, which is 0.8. Going up here, we have a value here of 10.01 and 10.09, giving us a value of 0.08 and this of 20. And so the area of that triangle will be 1/2 base times height, 1/2 0.08 times the height, which is 20. So that gives us 10, and that's going to be 0.8. So what we find is the delta V's are equal, the masses are equal, so the impulses are approximately equal. So that does mean that B is one of our choices. Car B experiences a non-zero force for a longer time than car A. Well, what we know is that F net equals ma. So a non-zero force, a zero force, means that the acceleration is 0. Acceleration is 0 during the red, so non-zero means the other green. So it's saying B has a non-zero force for a longer period of time than car A. And that is false. It has a shorter. So that is out. Change of momentum for car B occurs over a shorter period of time than for car A. And that is definitely true. So that is choices B and D.